One repeated question that we had is, I think people in the chat are concerned of environmental sustainability. It seems as if, or I'm paraphrasing, so this is a question for everybody. It seems as if they're concerned in what type of energy, how much energy it requires to basically, and let's just make the assumption that we're replacing humans with machine. And tied to that, they're also concerned, you mentioned hybrid motors and so on, if potentially that machine fruit interaction can affect the quality of the fruit. So it's all related to energy usage. And if you could just pitch in, if there's even any considerations in that field. They also mentioned life cycle assessment in terms of energy efficiency and so on. We can start with that discussion and hopefully that takes us elsewhere.
I'm going to say right away, because I'm the one that's worked most with field crews, is that if you did a life cycle assessment and you considered what it took to get those crews to the field, to house them, to support them, and basically also just the expense of paying them, the situation with mechanical harvesting is much more sustainable from a point of view of getting the crop to market economically. That's, of course, I don't have numbers to support that, but having worked with crews of 100s in the orchards down in Argentina with all of us, where these poor guys were living under tarps out in the orchard, they were all Bolivians. I just know that the inputs are greater than any input to run a machine and get it to the field.
Yeah, and there's a lot of considerations around that space. I think one thing to remember is that, and strawberries might be slightly different, but all crops have a finite growing season, right? And so, a mechanical harvester in some applications, you're going to run maybe 200 hours in the entire year. If you're a contract harvester and you're going to do a bunch of varieties, maybe you would put on 1,000 hours. And when you look at the efficiency of Tier 4 and Stage 5 extensions.
Okay, thank you. That's all the problem there. Thanks.
I feel a little bit pressure to say something impressive now.
So you were saying.
I'll hand it off to you here in a second. So it's both about, I think, hours usage. It's about efficiency of diesel engines today, fuel consumption, eco mode. All of our stuff runs eco mode, right? So in the old days, you used to run the engine at 4 p.m. to run all the functions. Now you run the engine up only when you need it. And then talking about hybrid engines and electrification of subsystems. So it's all part of the sustainability piece.
Yeah, I guess the only couple of things I would add are, one, we have to play the long game. So, we're talking about precision ag, and precision ag means a future like Louise made it, where there's a lot of more specialized pieces of farm equipment, more right sized for their task. Tractors are wonderful because they're so diverse and powerful. You can do almost anything, if you have the right tractor. But what we need to move to is a model where it's not about one tractor or a few tractors, big tractors that can do everything, but rather more energy efficient, right-sized pieces of equipment that can do specific tasks much better. And so I think that's the long game, and it may not be obvious now, but I think that will eventually mean more energy efficiency at the farm level. And I would also say, from my experience, to address the question that Erwin posed, I don't think there's any impact on fruit quality that's related to energy efficiency, but maybe someone else sees it.
I have one other thing.
So anything to add?
One other thing I wanted to add was the harvesters I've grown up around are gigantic behemoths and, like a colossus. That's a the same kind of harvesting technology that I used that you saw in machines from Oxbo. Those machines are $1 million or more, but the technology could be very easily put on smaller platforms, as Kyle pointed out. And this means that a small grower could own one machine and a large grower could own 10. And when one piece of machinery goes down, their whole operation doesn't go down. And that's better than having to have a mechanic in the field 24/7 if you're running a big harvester. So I do think the whole push is towards smaller trees and smaller, more discrete pieces of harvesting equipment. Stavros, you got anything to add?
No, I will agree. I mean, the application of robotic harvesting is kind of orthogonal to the technology of the prime mover, what is towing or moving this equipment. We see a lot of effort on electrification, electric autonomous tractors. So that's one thing. The other is that I agree, as we get to autonomy, we will see fleets that may involve more smaller machines, and many smaller machines that can be optimized for efficiency, energy efficiency. Two more things. One is that, like Kyle said, if you are not human-centric, then you may reorganize your entire operation from the field to the packing house. That can be also re-optimized for efficiency. And last but not least, if you have hundreds of people driving with their sometimes old cars to the fields to harvest, that's a lot of gas there.
Mm-hmm.
And that's what's happening now. So I'm very optimistic that robotic harvesting and mechanized harvesting will lead to fuel efficiencies and not only fuel, but electrification and independence from fossil fuels.
So something that I noticed is that it seems as if we're offering two different solutions. And I even, when I was approaching panelists for this session, we have a robotics representative and mechanized harvesting representative. Are we doing anything to work in parallel? In other words, we attach a robotic solution to a mechanical harvester so that you can work succinctly in solving specific problems that we can't solve right now separately.
Yes.
Yes.
I know, yes. Could you offer an example of where that would be helpful to you, for example? How could you work together with Kyle to offer a potential solution that you can?
Yeah, there's definitely conversations that I've been involved in, maybe not with Kyle specifically, right? But there are industry groups that I alluded to earlier that are pulling together both the robotic piece, the platform piece to understand, and you alluded to it in your conversation, it's about maybe a common tech stack. It's about, even in our own equipment, right? It's about common technology that can then be used to extend new technologies. Yeah, so there have definitely been conversations in the industry around specialty crops. I've been involved in them for the last 18 months, a really concerted effort saying, hey, how can we pull together people who are doing different things in this space, work together, because no single crop, it appears that no single crop and no single company is going to be able to solve all of this on their own. And I guess I look at it like I don't make engines, right? When it's appropriate, I buy them, which is always right. And there are some technologies that we make and some technologies that we source from other industries. So why, I wouldn't draw the line to say we wouldn't source robotic pieces of technology on mechanical platforms or things that are more interchangeable.
I want to hear what Stavros has to say first, and then I want to comment.
Well, something interesting that's happening is that people have to reinvent the wheel So, if you have a startup, they have to do their own autonomy, they have to do their own perception, they have to do their own safety, all of these things. And those things require resources. And many of them they can do, but it costs, and maybe it slows down progress in other fronts. And so it would be great if it were possible to get, let's say, an autonomous navigation stack from company X, and then not have to develop it yourself. As an idea, it's great. The problem is that specialty crops are so different from each other that sometimes a generic solution doesn't really work well. There are also other issues related to intellectual property, blah, blah, blah. In terms of collaboration with universities, I mean, for sure, when there is complementarity, that can be done. For example, if you need to work with breeders, or if you want to do post-harvest quality for your experiments, the university would be a great collaborator for these things. Something else that could be done is, if you want to do something that's high risk exploratory, but you don't have the resources and you don't have the time to do that, then that could be a project that could be undertaken between industry and academia, for example. And then other examples could be improving things. For example, you may have some algorithms to do X, autonomous navigation or grasping a berry. And maybe you want to improve on that, but you don't have the resources or time to do that. And there is no new IP involved. It's more, tuning or coming up with slightly different solutions. Then that's also something that could be done in a collaboration with, for example, a university or a research institute. So I think there are opportunities, but we tend to work a lot in compartmentalized labs, and there is also a lot of skepticism and related to IP, intellectual property, and that's understandable. And I think that fear, and also the different time scales of academic institutions and startups, are obstacles that have made it more difficult for collaboration to initiate. But it's happening. It doesn't mean that it's not happening.
Yeah, I was hoping I would be able to think through a really articulate answer while Stavros was talking about work. No, first of all, I want to be part of those discussions you guys are having, because that sounds great. I think the tough part for me is it's a fine line between mechanical and robotic harvest, and I think it probably means something different to everyone else. But let's just say that I'll give you an example of how our system works in a way it's kind of hard to detangle. We like to say that we have we built a dumb cheap robot, because if you think about it in a factory, if you think back to Stavros' example, the difference between autonomy and robotics, you can design the whole factory around the robot. You can design the lighting, you can design the conveyor belt speed, and you expect that robot to be able to go to the same place within 1.1 millimeters of accuracy over and over and over again. But we don't have the luxury of doing that, because we can hit a bomb, right? Or a leaf can fly in the middle of or over the strawberry after we've seen it. And so we have to have super tight systems level integration. Everything from we have to know how fast we're driving, and how many frames a second we're seeing with our camera, and how our position has changed since the last picture we saw, and et cetera, et cetera, et cetera. And it's really hard to pull that apart and bolt it onto something else, let's say, which is why we unfortunately have to build so much of the tech stack. Now, 10, 20 years from now, you can totally see a situation where we have enough experience with our stereo camera and with enough different applications of our stereo camera that we can commercialize and someone can get a head start versus where we started from, where we had to design everything from scratch. But I do think it's quite a ways until those building blocks become robust and well understood, and also that the ecosystems around them have developed enough such that they can be sort of plug and play. I think it's a valiant effort and one that we should all pay some attention to, but as Stavros said too, the incentives are really hard to align there. And so anyway, it's a great question, and not something that could be, it seems obvious to me. Where it does seem a little bit more obvious, there's two ways. Timed together with harvest dates, I think is a really interesting, kind of operational mindset that can be a operational link, not necessarily a direct mechanical link, between harvesting and harvesting aids. And then the second one is drawing analogs from other industries, right? So, for example, when we see strawberry autonomous sorting, packing strawberries, that's well understood in a lot of other industries. And so I think we can draw inspiration from those and adapt the system that will also benefit robotic harvesting and some of these other aspects of automation, but not necessarily directly like smashing two solutions together to make it work. I don't think that's going to work very often.
So, just Patricia, yeah, I was just going to ask you to contribute, because you mentioned something about how changing the way we harvest, like in the differences between South America and the US. So you can add to that, but if you have another question. Yeah, thank you. Well, my question to Kyle, I was, well, I think great presentation. I was very impressed with the robots and the harvest equipment.
Thank you.
And definitely we will be in touch. We'll do some strawberries as well. But I am wondering how or what type of technology are you guys using or incorporating to determining what is the right harvest index for the strawberries? Because how can right between ripe or ripe, so what type of camera?
Yeah, sure. So we have our own stereo camera that looks just on the color scale, looks for red and green, and then we use machine learning and trained models to help us understand what is a right area or not, depending on the hue of the red and the shoulder, the width of the green versus red shoulder, and the shape of the strawberry, if it's a cluster, if it's by itself, all these things. So we train machine learning models, and we're making those decisions in real time, which is another part of this challenge. We have to see a berry and then decide all of those things while we're on our way to the berry, right? And then pick it successfully. So that requires a certain type of compute power that we also have that we use while we're making that decision.
Perfect.
Yeah, with the NVIDIA system.
Thank you. And any advances or progress in grapes from both of you guys? Are you considering explore the grapes?
Table
grapes? Yes.
Yeah, I think if you look at the problem really broadly, it is. I think all of the fresh produce that's picked by hand right now will eventually be picked, or most of it will eventually be picked by machines. And I think if you look at the market size, strawberries, apples, and grapes are among the most interesting. Just to Louise's point, it's always challenging when you really want to mechanize or automate something and the market size is smaller, the economics don't favor sort of private industry generating business around it. I think grapes is definitely one of those areas where it's really interesting and the technological problem is really hard. And so I think you'll see people try to tackle it, and we'd love to tackle it.
Thank you, Rex.
Kathryn.
I agree. I've been on a couple of groups taking a look at table grape harvest, and to the point where it is extremely challenging. And in some consumer behavior, we need to change. Right? There's a lot that goes on when you harvest table grapes. You're not just grabbing the cluster, right? They're cleaning them up. They're common sizes. There's a lot to that process. I think the burrow is a great first step. So we haven't spent time looking at the burrow in the fields. That's a good first step. But then the complicated next step, right? It's under the vine and off the vine at the same time. So you get a space constraint from a height perspective, and you've got non-uniform clusters. It's a fun one.
Yeah.
I think it'll be down the road a little bit, just based on what I've seen from robotics, where we are with vision, where we are with degrees of freedom. There's a clip and clean. There's a lot of stages to table grapes. So yes, but I think we need to be patient for a bit.
Yeah, no, thank you. Yeah, we're exploring Guru as well.
Yeah.
Currently, it's a really good autonomous, and I heard they are connecting with other partners like Bloomfield, AI cameras to also calculate the yields, and apparently it's working well. So I think it's interesting to see this merge between companies because can we achieve important things.
So, sir? Oh, he's got it. Sorry, I forgot this is ours.
Yeah, Kyle, you mentioned one person can attend to 5 machines. Mm-hmm. And yesterday, during FarmWire's presentation, I think the regulation came up that you have one person have to be within 10 feet of an autonomous machine. Does that constrain what you're able to do in terms of multiple small machines?
Yeah, great question, nuanced question. I think that the California guidelines are always, well, they're not changing fast enough, I would say, but there's some restrictions around furrow guided equipment, which is what we have, and then non-furrow guided equipment, so more autonomous navigation. I think we very much conform to the furrow guided equipment.
How deep does it have to be before you call it furrow?
Good question. But I think it's say under 2 miles an hour, be within a reaching distance without obstacles controls. And I think if you came to see our operation, you'd be very comfortable that we've kept all of those regulations in mind. And certainly we've been very fortunate to have great customers who sort of helped us learn with them on how to implement those on the ranch.
I have a question regarding the strawberries. When you are picking them, you have a suction. My question is the suction not strong to damage the strawberries? I mean, normally when they harvest them by hand, it's a gentle. When you are actually pulling them, are you sure or not that you are not damaging that? And also, the second question is regarding when you have people harvesting, they harvest and put directly in clamshells.
Right.
So when you are using the machine also has a section where they put the strawberries in clamshell, or there has to be people to handle them again and put them in clamshell.
Sure. Yeah. So when we
I have another question added to this thing. Like, is it possible to put a cooling chamber in the device of the machine, so you can just put it in like a hole? It's called.
No, very, very, very cool questions. Thanks for your ideas. I think so. To give you my experience in going out to a ranch and seeing other companies try to go out to a ranch, maybe the first thing that the grower asks you is, "Are you going to damage our food, or are you going to hurt our field, or, yield, etc." So we tried to de-risk that problem quite a bit at the beginning. Vic Ripper that you saw in the video is probably the 100th version, barely exaggerating. For 4 years, we continued to tweak and tune it. And I'd say, so the short answer is no, right? We wouldn't be allowed to pick millions of berries without demonstrating early on that we don't damage fruit. I would say we do damage fruit when we don't pick the fruit correctly, right? So when we go down and mess up, then we damage the fruit. Or, you know, if it's a really hot day and it's 2 p.m. and it's a soft variety, it's not going to be our ideal situation. But these are all the things where we talk about, you know, the systems level optimization needs to change a bit. We need to harvest that variety at night, you know, whatever the case may be. We harvest into the industry standard freezer trays, which are plastic totes. And this was sort of, again, if you remember my comment about minimizing friction for growers when we wanted to work with them. Growers have this, every grower has their own packing standard. And so what they told us is, hey, pick the fruit, we'll pack it to our standard. You know, first of all, it's hard to train a human to pack to that standard. It's almost impossible, if not impossible, to train a robot to pack to that standard. So just get them in the tote, and we'll pack from there. And then it also allowed for easy sanitation of the during the harvest process, because the totes are sent to the processing facility to be sanitized. So it was sort of very conformant to the current industry, you know, farming practices are conformant enough. As we've seen the volume of harvested fruit go way up, we've seen that the cost to sort it back is actually one of the biggest costs in the process. And so that's why part of the reason why we've taken on autonomous sorting and packing of strawberries, because we can significantly reduce that cost and still give growers, in fact, more flexibility to pack for their retail customers than they've ever had before. Because now you don't have to bring new types of packaging out to the field and train, you know, hundreds of workers on new type of packaging. You can make that switch in a cooler, and it's much faster. In terms of the pre-cooling chamber on the harvester, it's not something we probably could, but you know, there's a lot of science that I don't pretend to be very versed about with respect to post-harvest cooling, specifically removing the heat in pre-cool tunnels. And I think that's something that, from what I understand, is also very carefully controlled by grower shippers, and probably not something that we haven't been pressured to address that problem, because I think it's really well suited to be addressed at coolers after harvest. So our goal is really to get fruit off the plant and get it to the cooler faster than it's ever got there.
Yes, I just wanted to say this is something that we see a lot when we, whether it's robotics or it's mechanical harvesting, it's what can we also do, you know, the next step of the downstream process. And I think I want to caution, it's great, right? We like to get our minds around that and to see where that fits and where that doesn't fit. But adding complexity on a mobile platform is, you know, that can increase downtime. And it can take it away from its primary function. We start to add on different pieces. It's like, okay, there's a cool, you know, there's a shed or there's a processing facility that does a really good job of that. So to your point, let's get it there faster and let them do that well. And you know, it's early on with robotic apple harvesting, right? It's like we're trying to do too many things, and like each of those things is complex. So if one thing in the chain goes down, and you have a really complex system that's gone down. That's not to say that the future there won't be more of that infield, and we're taking a look at a lot of those ourselves from a mechanical harvesting perspective. But it's to say that base technology is so repeatable and so solid before you take on the next piece, or we're just not going to get there.
I have a question. You mentioned previously about grapes, and I was curious what you think might be the most difficult fruit to apply mechanical harvesting or robotic harvesting to, and do you think one day we might be able to automate everything?
I think the most difficult fruit to mechanically harvest is something that's heavy and tender. So believe it or not, a pomegranate. They have a thin, porous skin. They're very liable to pop. Yeah, she said it. And I watched the mechanical harvester I use with pomegranates, and that thing was backing out the rear end like baseball bats. I would like to add one thing about enhancing the value of the machines. I deal with the permanent crops, the trees and the vines, and something that would be lightweight and addable, and the and the technology has gotten so much better since I have started harvesting, is anything that helps us measure the metrics of the orchard in the sense of how much is coming off that tree, what areas of the tree am I not harvesting, so that when I go back, should I prune out that section of the tree? And all these would take is cameras and some kind of, I always get this word mixed up, NDVI, or near the vegetative index. But I think these kinds of sensors, I'll ask Stavros to tell me if I'm on the right track here. But I think sensors like that could help us with our design of the orchard or our improvements of the orchard in terms of how we manage it. And then just seeing how our yield flow is coming. Is there a bad spot in the orchard? Are we screwing up some way in our irrigation or our fertilization? I don't think it'll be the precision harvesting of grain crops, but it seems to me, and I'm not the engineer, that those sensors could be put on a machine with not a lot of weight, but of course, like everything engineering-wise, would take some thinking around to make work. What do you think, Stavros?
This is a great comment, and I agree. First of all, if you have a robotic harvester, you will get a stream of data at an amazing resolution. If we are talking trees, you could know which part of the tree a specific fruit came from, what was more productive, less productive, what time you got it. There is an amazing amount of data. I mean, there is even the possibility of laser tagging individual fruits that has been done and getting an amazing amount of information. Now, how do you use that information? That's another story. But there is probably going to be a lot of added value in it. I remember some time ago we developed a harvest aid for table grapes, and the company was saying the data we'll get out of it may be more important than the savings in labor. And so you can imagine that data traveling from the harvesting machine even to the packing house and further down. And what we haven't seen yet is possibly data coming back from the supermarket or the rest of the chain back into the production, which is also possible. So, and in certain cases, the differential cost of adding an extra camera or a different type of wavelength camera, etc., is not going to be that high. So I totally agree. There is a lot of added value to the data we will be getting from these types of machines.
I know right now that I can follow a machine and tell what I should have pruned out or what isn't going to harvest. And therefore I will prune it out, meaning by what branch breaks or what branch doesn't harvest. The other thing I would be interested in doing is better automating the flow of the processing plant, like for our pistachio processing plants. Sometimes you'll go there and there'll be 200 doubles, that's each one of them 50,000 pounds, sitting out there in the sun, waiting to get into the processing plant. If we had some way of better metering the amount of crops that was going to come into the processing plant, have the processing plant say, hey, cut out, I know, stop harvesting, we can't handle that capacity today. It'll sit in the sun, and all the loads of pistachios, before they're processed, they take the internal temperature on the load, because the internal temperature determines the breakdown of the hulls. The breakdown of the hulls stains the shells. The stained shells degrade the quality the grower gets. So if we had a better way of using our machinery to also monitor what gets to the processing plant, and the processing plant telling us we can't take that right now, it would also be helpful. And that doesn't seem to me like it would be that hard to do. But I'm not the engineer.
I was just going to add, Louise, I think what you, just hearing you say these things, it reinforces to me the importance of sort of agronomy in making this stuff work. We've always been challenged occasionally, hey, we should get an in-house agronomist, because I think, especially for a team that's new to farming, like we don't even know a lot of this problem. A lot of these insights don't come naturally to us, and so I think it speaks again to this need for really close collaboration between all of the stakeholders, and that's why, in our case, we rely on really forward-thinking growers who see something like, you know what, next year I'm going to do this differently, or I'm going to get this cultivar instead of that one. And something that, first of all, we never would have considered, but second of all, we're not in control of making those decisions in a lot of cases. So I think we will see increased collaboration, and I think that we will actually start to see more vertical integration too for the big olive oil manufacturers who decide they want to get into this can make those decisions. They have the domain expertise, and they'll bring along technologists with them to kind of get to where they need to be. But yeah, it was just on my mind when you said that.
Great.
Yeah, to your point, we're already leveraging technology that comes from other parts of the agricultural industry to drive the downstream process, because you're exactly right? The longer that any fresh produce sits somewhere, whether it's at the facility before it can be processed, whether it's in the field before it can get into a refrigerated trailer, wherever it is that it stops, where it gets hung up, it's bad for quality. Bad for quality is bad for consumers at the end of the day. And so we are using yield technology that's in more broad acre crops that we can then modify to work in specialty agriculture. And that's part of the key, right? Some of the stuff, there is some existing technology, so how can we leverage with partners and with growers to make it work in our application? So that's definitely pieces that we're doing. And to your question, I think grapes is the hardest, table grapes. That's my vote.
Tell us why.
Why do I think that? I think that because of all of the decision making that happens when a person is hand harvesting table grapes. The inspection, the rotating, and it's not just like in strawberries. You look at a strawberry and you say strawberry is ripe or ripe enough and point to pick it. Similar to apples, right? In a table grape, you have an entire cluster. And so you're looking at the cluster, and then on top of that, he's often cutting off, like, oh, that's not a very nice one, I'm not going to take that, I'll leave that on the ground. And they're cleaning it up, and then they're packaging it to a common size with a bunch of clusters together. And then add to that the complexity of a space constraint and a one directional under the canopy. And then I think about, you would have to probably have a partner technology, even with robotic harvesting of a burrow to run the stuff out, because you're underneath, right? You've got tons of grapes, literally, probably, right? And it can be a multi-pass application. So I think all of those things together, you can't drop it from a super high height, right? You're gonna break the skin. So I think grapes might win the prize.
We talk about melons for a minute.
That's a close second.
Yeah. So the challenges that we see on the west side are obviously mostly involved with water, but then also the labor situation. Western style cantaloupes, we have to pass every day. Majority of growers are now out of that, which is highly unfortunate because it's high flavor, wonderful melon, and they're moving into the ESLs or LSLs. That being said, is there any discussion, anything in the works for melons? And also, we talk separately about watermelons, because to me, the watermelon cutter is the most skilled of the labor.
Sure, you can start.
That melon, the changes in the melon market have been really interesting to watch. In particular, we, again, in a kind of a hopeful collaboration with breeders, there's the move to to move back to a selective harvest and then have the kind of the change in color on the melon, on the outside of the melon. That would help inform robotic harvest, right? What's big and what's not big, but it is a very subtle color change from what I can tell, and it's going to be a big challenge. So I think that there, and also, that's another one where we run the numbers. It's super interesting from a technical point of view. I think it could be solved if the differentiation of the melon color is distinct enough, but the market size is challenging. I think it's probably like 90 million, $100 million market. And when you start to talk about venture firms that really want to invest their money in technologies, or even corporations that are trying to branch into new technologies, unless it's directly transferable and really high ROI, it's hard to spin up a business for that and get funded. So that's where I've seen it ballpark so far.
It's a tough one. Yeah, we've taken a lot of great kind of conversations, but I think to your point, right? It's market size. It's a heavy product too, right? So it's difficult. It's on the ground. It's heavy, and there's a lot going on. So I don't know. It's probably a toss-up between melons and table grapes.
We have a couple of melon experts here, so let's hear from them.
I used to work quite a bit with melons. I just wanted to say, instead of for the cantaloupes, instead of the external color, the key indicator that we have for the maturity of the high quality melons has to do with the stem begins to separate.
Yeah.
And so that's a very, that's unique. So the external color is less consistent. So it's that separation that's been bred out in the extra long shelf life of melons that's the problem. And now they're being cut.
Okay.
But then thinking about also the other even smaller group, before you completely dismiss melons, okay, from these considerations, we have the situation of, for example, the honeydew melons, where expert harvesters, it's a tactile sense, because again, the color itself is not a good indicator, but it goes from a fuzzy stage to what I call bald head or holy ball stage, and then it goes to a tackiness as the wax develops. And those that harvest well, and if the growers allow the workers sufficient time, that tactile sense of the melons is really key to determining the correct stage of maturity. Once they're harvested and put into the bins, now they're just moving product around, and they've lost that ability. So there's some really unique characteristics there. But again, I'm not optimistic, because again, the size of the market is very small. But there's some unique challenges there too. Harvesting in a less human way, getting humans out of the harvest and doing it with robotics or but there were some key indicators. That's what I'm going to say. There's some key indicators that are very unique.
I just wanted to add that, as I look at, I've been involved in a lot of different groups, right? I think when you look at the produce industry, between robotics and mechanical harvesting, I think it's our job to help free up the labor from the markets where we can, so that they can go to the markets where the challenge, either the acreage is small or the challenges are really hard, and free up that extremely skilled labor to do what we need extremely skilled labor, and to give technology some time to catch up. To your comment about platforms earlier, I think we will get there. And so when I look at it, it's like, okay, you've got chemical harvesting or robotic harvesting. Let's get those things in the field where it makes sense. Let's free up the labor to be able to help out the other industries. And maybe it's pruning, right? I mean, we haven't even talked about, all we talked about today is just about the harvesting of the crop, right? But that's not the only activity going on in the field. And so we have some skilled labor, and we need it in certain places. Melons could be one of those places, and probably is, right? Pruning is typically in fruit crops one of those places. So I think we look at it as a larger industry, as we all have to help each other in some respects.
I have a question for Stavros. So or to all the machine people, do you ever think in the future there'll be places for sensors that are sensors of volatility or density?
Yeah, that's an excellent question and actually ties well to the previous topic of melons. In general, for some crops, the biggest problem or bottleneck is that you can't really sense whether the crop is there or it's ready to be picked. Um, and this is an example where high risk projects are and could be undertaken by academia to look into ways to solve these problems. I'll just mention an example. You know, we are working on a project for cauliflower. I mean, how do you harvest cauliflower? The head is wrapped around in a lot of foliage. You can't even see if there is a head, how big it is, if it should be harvested. If you're a human, it's very difficult. You know, they have long knives and they try to open up the canopy, etc. But we should not always try to imitate human skill. In our case, in this project, for example, we are using high frequency radio waves, and it turns out that there is a very good possibility that we can do that by proximal sensing. So going back to melons, you know, you may be able to assess ripeness with other sensing modalities that humans lack. I'm not saying that it's doable. It might be, but it's not something that most likely a startup would bet their resources on, because it's a very high risk endeavor. And so on your question, Louise, there is a lot of different sensors out there and sensing modalities. You know, how each one can be used to assess properties of the fruit or the crop that will determine if it's harvestable, or you know, what is the quality, or when it should be harvested. That's quite an open frontier, and work is being done, and I think will continue to be done, and in some cases we'll see real results.
Could I add one small comment again about the melons? Is that we know from a physiological standpoint that if we measure internal ethylene, that's very tied to then specific quality. And more than 20 years ago, researchers in the Midwest, I think out of Indiana or Illinois, developed a sensor like a suction cup to extract some of the volatiles and try to determine the ethylene. Well, it's successful, but just too slow. So that never came to market. But the concept and the idea, again, trying to use the volatiles, and we know that physiologically, that relationship between the ethylene production and the time to harvest, we do that in the lab. We actually insert a long needle, take an internal ethylene sample, and that's how we classify the melons when we're doing storages for specific stages of maturity. But just how do you translate that into something that's, you know, practical?
Yeah, that's what these
I
are.
mean, you could
On your left-hand side. To answer that question.
My name is Mitchell McCartney. I work with Professor Davis here on campus. And at 2 o'clock, I'm giving a talk on some sensors to measure volatile compounds related to produce quality. So I may plug myself.
There you go.
So,
I think we have time for one more comment.
It's more common, I guess. My question actually, Louise asked, so thanks, Louise. I was going to ask that as well. We did do a project probably 8 years ago now with melons, where we did show that there is definitely a different volatile profile between mature ripe melons and immature. And that was done using a Z-Nose, which is this rapid volatile sensing machine, which is no longer on the market. But anyway, so it does seem like it's possible, but is it practical and affordable? That's the question. But I was just going to say, given the kind of information that Dr. Cantwell was imparting here, you know, maybe, I don't know how big your companies are, but you might want to consider sending some colleagues to our post-harvest short course. We can learn about harvest maturity and handling of a wide range of commodities. It could be interesting for future development, but also for the crops that we're currently handling. We have that coming up in June.
this year, so. Put a little plug in for that.
We'll be there.
So,
We'll be there.
Erwin, I think it's probably time that we
I would prefer to have lunch in here and continue talking with this expert, but no, we're not gonna do that. Don't
what do you mean, we don't get lunch?
Please join me in thanking the panelists again. Thank you.
Just like to close by saying what I learned in this session really reaffirms and extends what I was thinking, which we can see how these emerging technologies come out of university and private cooperations all the way down to the grower telling us, yeah, that worked hot, that didn't work so hot. And that's the kind of thing that we have to foster to get a greater integration of the production of the crop through the harvesting and to the final net return for all of us.
Definitely. Thank you, Louise. A couple of announcements before you head out for lunch. Just want to remind that this evening we'll be heading to the Hyatt Place. That's how it's called, Hyatt Place. We're inviting you to have some drinks with us if you're interested and continue this conversation. Please don't inundate our panelists with many more questions. I know you have many more, but at least allow them to eat. That's it. And with that, thank you again, and we'll see you later this afternoon. The session this afternoon is related to sensing, which has already been kind of addressed right now, but we'll dive specifically into that topic. Thanks again.